Welcome to Phytops. We listen to plants. Well, not right now. Now we are building the device that is needed to be able to listen to plants. What I'm talking about is the plant voltage recorder, and this is part 3 of building a plant voltage recorder. In part 1 and 2 I've walked you through the individual components of the recorder, micro SD, STM amplifier and the battery. In part 2 I've shown you what they look like in real life. In part 3 I'm going to show you what they look like when they're assembled. So what do we have here? This is, if you remember, the STM microcontroller here, this one, that I mentioned in part 2 and that I've shown you in part 2, connected with these wires here to the micro SD module, which is this one. So basically we have these two components here. These wires here are for the battery connection, and I'm going to come to that. Let's see if this holds. Yes. So now what's missing is the amplifier. I did show you in part 2 this amplifier, which is pretty much, well, not the very first, but almost one of the first amplifiers I built for this. This is version 2. Version 1 is does not exist anymore. Actually, it was just a concept on a breadboard. This is version 2, which I put together with some simple components. And there's version 3, which is this one, which is newly designed, and I had it fabricated. Version 3 is still in the beta testing phase, so I'm just showing it here. We're not connected for operations. But version 2, despite its homebrew appearance, has been working excellently for me throughout the past year and a half, nearly 2 years. So it's reliable and does what it needs to do. To connect this to the rest, well, unfortunately I have a set of male connectors here, which is bad because it would need to connect to pins A0 and A1, which are here, right? Those two pins would be connected to these two. So ideally I'd have either a sort of what you call a gender changer cable or a female ends here. These two female ends are for the electrodes. The rest is power, these two. This is ground. And this is an additional battery that I just need for the amplifier. An additional battery to the main battery. While that is, well, it would be ideal if we didn't have to have this additional battery just for the amplifier, but it works like this, it's fine. But getting rid of that additional battery was one of the reasons why I designed the version 3, because this one doesn't actually need the additional battery. So, in contrast to what I just said to you a couple of minutes ago, I'm going to connect this one, the new version, and version 3, and put version 2 on hold, because it's just simpler that way. So, how do we connect this? Start with power. Or let's start with ground. So the amp module needs ground. Here the black wire, and ground we get from this pin. Alright. We also need 3.3 volts, which we can get from this pin. Yes. Then the amplifier, do it like this. The amplifier has outputs, so the amplified electrode signals come out here in green and blue. Green is the first one, so it needs to be connected to A0. That's that. Blue is the second. It needs to be connected to A1. So these two pins here, A0 and A1, are analog to digital converter pins of the microcontroller. Right, so we have power, we have the inputs, and basically that's it already. Wow, okay, let's look at what else is here. These two, E1 and E2, go to the tree, base of the trunk, upper third of the tree. This one is earth. This goes to an electrode sticking in the ground. So these things obviously will need to be built, but that's easy, very easy to do since they're just normal isolated cables with steel rods or steel needles at the end. Right? So these I will ignore. Then to make the whole thing operational, we need a micro SD card to put in this slot. And then, assuming it's properly programmed, which it is not right now, because it is not, we connect it to power. Power, in my case, is this 18650 battery that I've shown you in part 2. Which is now connected, and I'm connecting to blue, which should be ground. Let's see. This is correct, yes, because I don't want to fry this thing. If you don't get the polarity right, there's one last blink of the microcontroller and then it's gone forever. So believe me, I've done it often enough. I don't want to do it right now. And this is the 5-volt input of the microcontroller, which we connect directly to the output of the battery. And we see, red light indicates power is okay. We saw a blinking green light, which just means that, let me show you again, which just means that the microcontroller is telling us, hey, I've been programmed, you're giving me power, what should I do? Right? So that's the whole thing. This thing that, whoops, better switch off. So with this properly programmed, we just put all of this into a case. You can actually see what one example of a case would look like in the other videos I've done in the field next to the conifer I'm recording. And that's it. Then put this in a case with the electrodes, you can start recording. Now, Now the software for programming this is obviously a different issue, but is not a Nobel worthy endeavor to have that. I will share at some point the basic sketch that you need to program this microcontroller. And so let me pull out this last cable so I don't make any more mistakes here. Put this, well, leave it like it is. And then thank you for watching. There will be more videos on other aspects of plant voltage recording, plant voltage analyzing and interpretation, but that's for future videos. Okay, thanks, bye-bye.